This video explains how to use the Trace32 logger trace. The Trace32 logger is a software trace method that is mainly used when no hardware-based trace is available. This trace method requires a modification of the target application in order to write specific trace information to the reserved buffer on the target memory using a trace format provided by Lauterbach. Trace32 then loads the trace information from the target memory for processing and display. In this video, we use a Trace32 PowerView for ARM version of March 2021 and a PowerDebug USB 3 connected to a Cortex-A9 processor. C and C++ sources and header files for using the Trace32 logger are available in the Trace32 system directory under Demo, etc, logger. Whenever a part of the application uses the logger, the header file logger.h or logger.hpp must be included. When compiling and linking the application, the logger file logger.c or logger.cpp must be additionally handled as normal source components of the application. Next thing to do is to instrument the target application to include the logger calls. The T32 logger init function has to be added at the start of the application in order to initialize the logger internal data structures. The T32 logger data can then be used to add data to the logger trace. In this example, we'll log the write accesses to the 32 variable mcount and the 16-bit variable plot1. In order to set up the Trace32 logger, we first need to define the address of the logger trace buffer in target memory using the command logger.address. Then we need to execute the function T32 logger init. Finally, we now need to initialize the logger by pressing the init button. After the initialization, the size field contains the size of the logger trace. Let's let the program run for a couple of seconds. We can see that the logger buffer is full. The logger trace contents can be displayed now by pushing the list button. The logger list window displays per default the logged address, access type, data value, and symbolic information. We can additionally use the logger.draw.var command in order to display the recorded data values graphically. In the second example, I have additionally instrumented the entry of selected functions with a call of the T32 logger data function, but using T32 fetch as first parameter. We see now that we have the fetch accesses in the logger results, with the name of the corresponding function under symbol. The function activity chart can be displayed by pressing the chart button. If you want to include time information in the logger trace, then you need to implement the T32 timer init and T32 timer get functions using an architecture-specific time. Please refer for detailed description about the logger functions to the application note for the logger trace. Thank you for your attention.